in a better way what Razvan then will show us. Not sure how many of you are really familiar with OpenSIPS, but it's kind of a short, I wouldn't say introduction, but a short label on OpenSIPS. So SIP proxy, and right now it's moving into more like a SIP server. It's with a long history behind it as a project. It's a well-known project. How many calls are actually routed the world by using different kind of OpenSIPS based platforms, because that's one of the beauties of OpenSIPS. It's an programmable SIP server, so it's up to you what you want OpenSIPS to do. You are just provisioning in terms of scripting, so you are programming a logic inside OpenSIPS to tell it what to do, so it can act as let's say as an SBC, as a regular proxy, as a registrar server, as presence server, as balancer, and so on. So that's the part with being highly customizable with the scripting logic. Razvan will show us how easy it is actually to integrate the calling API into the default OpenSIPS script, and to be able to make a few calls. And of course, this ability to program your logic into OpenSIPS, it's backed up by a quite impressive set of modules. I think right now there are more than 155. I think these were for the 3.0 release. Now we are at 3.1. And usually we have like roughly maybe 3 to 4, even 5 modules each, new modules each release. So we are somewhere around 160 modules, which do offer different kind of functionalities, backends for databases, for events, routing engines, presence related modules, and so on. And one of the things that actually made OpenSIPS quite popular, it's the high throughput it's able to provide. So whenever you need to handle quite a lot of traffic, OpenSIPS is a very good platform to start with, because you can easily put like probably hundreds of thousands of registrations you can do on a single server or single instance. You can do maybe even thousands of calls per second, and not to mention like 10,000, 100,000 of concurrent call. Of course, at the end depends on how complex your logic is, but in terms of being able to cope with calls, registrations, and so on, it's a very scalable platform. But now let's see exactly how the whole story with the calling API started. As I said in the very beginning, historically speaking, OpenSIPS started as a SIP proxy, which basically by default limits a bit what OpenSIPS can do. Basically receives calls and you route them, send them further. So that's basically what the SIP proxy does, again, in terms of handling calls. So basically a call, it's a single, from logical perspective, it's a single entity. There are no separate legs for caller and callee, because you act as a proxy. The proxy do not separate the caller and callee legs. It's a single entity. And also what a SIP proxy can do in terms of manipulating the two ends of the call. A SIP proxy, it's quite limited. It cannot change or cannot manipulate individually the end party party once the call is established. So once you have a call between A and B, again, there is not much a proxy can do in order to eventually, let's say, change the part, separate the two parties in order to make them talk to some media server or anything like this. And because I mentioned the thing with the media server, it was being mentioning that because OpenSIPS is a SIP proxy, it does not provide by itself any kind of media capabilities. Nevertheless, it's able to do some media magic by interacting with external entities like RTP proxy or media proxy RTP engine, so external applications that may handle RTP. So we may say that this level of a SIP proxy limits a bit the flexibility of OpenSIPS in terms of doing advanced manipulation of calls once the calls are established. Even more, in terms of being a SIP server, so a bit far away from what an application server can do, the signaling or the processing that is done in OpenSIPS is triggered by incoming traffic. So because that's what a proxy does. It receives traffic and sends it further. So that's a bit of a limitation if you try to make OpenSIPS, let's say, triggering signaling by itself. So by default, that's a bit difficult to do it. And in the same time, the same as a media, OpenSIPS cannot stream or record. So automatically we see, okay, there are a lot of advantages in using OpenSIPS. So the flexibility, the fact that you have a lot of modules with a lot of functionalities, the fact that you can combine them as you want by using the programming language, the so-called OpenSIPS script. Nevertheless, because again, historically speaking, it's a SIP proxy, there are some limitations in terms of what we can do with the media and what we can do with the calls. Wanted to address in an easy way, in a nice packed way, by building this call API as a separate project that can be used with OpenSIPS, and in a very simple way, it will address almost all the problems that I mentioned before. For example, definitely being an API, in this case, you can trigger actions on the SIP traffic coming from outside, from API. You can handle quite complex SIP scenarios in a very simple way. Like I can start a call between two parties, I can transfer a call, or I can stop a call. So these are things that even before you are able to do with OpenSIPS, but maybe not so easy. You had to put too many things together, to use MI interfaces, to use event interfaces, to combine a lot of scripting and so on. So basically, the API is packing a lot of existing capabilities in OpenSIPS and providing them in a quite easy way further through this WebSocket-based API. And because we are able to pack different kind of functionalities in OpenSIPS and present them in a simple way through the API, we can also, in this case, use a lot of advanced in-dialog SIP handling in order to, let's say, move a bit OpenSIPS from this SIP proxy position into something more like a not necessarily like a B2B, but in terms of being able to manipulate a bit existing calls in order to do some nice features. We will see during the workshop. So an overview of how this call API looks like, starting from left to right. Basically, let's say that would be like a top level. We have an application layer. You can have applications like, maybe your own scripts, web-based applications, whatever, that may use this WebSocket-based API that we have right now. The API it's bidirectional, so the applications may trigger actions into the call API, and depending on what's happening, this may report back events. So you can get a status or an understanding of what's going on. Razvan will show some really cool stuff on that. The calling API talks further with OpenSIPS, so interacts with OpenSIPS using the OpenSIPS management interface in order to trigger actions inside OpenSIPS, and also it's registering and fetching different kind of events from OpenSIPS through the event interface, the heavy interface. And OpenSIPS further, basically at this point, it's used as a SIP stack, and OpenSIPS is the one signaling between different kind of SIP entities. So basically, we have these three layers. We have the WebSockets, then on top of the calling API, then the MI and AV interfaces between the calling API and OpenSIPS, and then the whole SIP, it's done by OpenSIPS. So basically, you will see the application layer can do a lot of, let's say, calling without being aware of how SIP works, or even without being aware of how OpenSIPS works. So it's a very abstract layer provided by the call API. This API is written in Go language. Has a it's a quite a scalable application in terms of using. So it can actually be used from multiple endpoints. It can also scale on the OpenSIPS layer. So when we designed it, we took into consideration to be able to scale at all levels. The communication through with the API, as I said, it's through the WebSockets. Everything it's JSON RPC in terms of, or JSON in terms of packing the actual data, the commands sent to the API, and also the events sent back by the API. In order to achieve scalability and also to avoid any kind of, to be more efficient in terms of using resources, everything, it's the interaction with the API, it's asynchronous. So there are no risks to block the application or even how the events are pushed back. It's also based on asynchronous JSON RPC notifications. And the API has a very modular design for, let's say, whoever is interested in developing, ideally, let's say, more commands, more scenario in terms of call handling. You will find it very easy to do it. Again, Razvan during the workshop will show the installation part, the deployment, the configuration, but also he will run some calls, some scenario with you. So just to give you an idea of how the interaction works between all these layers that we have, I just try to make a visual representation of that. Again, starting from left to right. So on the left side, we have the application through with the call API through the WebSockets. Sending in this example, we have a start call command, and then the API translates these commands in one or multiple commands towards OpenSIPS. Like in this case, first it will instruct OpenSIPS to start a new call. and OpenSIPS will initiate a SIP call with the first entity, with the SIP caller. In this case, it will send an invite, wait for the 200 OK, and then OpenSIPS will report this 200 OK to the API, and API further it will say, okay, we are about, the call is actually started, and after that answered, the caller answered the call. Once we have this first leg of the call, the API will tell OpenSIPS, okay, transfer this call, basically transfer caller to talk to the callee. And this will translate by OpenSIPS into sending a refer and the by in the original call. And then following the refer, the caller will actually get in touch with the callee. So the caller will send a call that through the OpenSIPS will reach back the callee. So basically, that's the whole mechanism to make the caller actually talking to the callee. As you see, in terms of SIP signaling things, okay, I'm not saying they are really complicated, but they are not so trivial. You need a lot of knowledge and a lot of effort in order to make it happen. To script all these. OpenSIPS offers the first level of, let's say, simplification by providing a set of MI commands that helps you in building this scenario. And on top of this, the calling API basically simplifies even more by providing, at least for this scenario, a single command and a set of events just to understand you what is going on. During the workshop, we will have not only this starting call, which is a quite basic scenario. Of course, we will be able to show starting, terminating call, putting call on hold, off hold, and even more, something really cool, to actually do an unattended transfer between existing calls. So basically, through the API, you are not only able to manipulate calls, but you can also monitor the calls by watching the events that you have and push further commands through the API for the ongoing calls. So Razvan, again, it will take over and continue. Nevertheless, if you want to learn more about this, in roughly 1 month from now, we're gonna have, of course, online the summit, when we're gonna the Open Summit, where we're gonna talk more about this cool new feature of OpenSIPS 3.1, and nevertheless of other such features. So Razvan, if you're able, if you are ready to start and show the more interesting part, the real stuff, the technical things, whenever you are ready.
Sure. Thank you, Bogdan. I'm going to grab your screen share now. Do you see my screen now?
Not yet.
Nope. Okay. Let me try to start it again.
Bogdan, can you remove your screen share if you still have one going?
I did so.
Okay.
If I'm not wrong, there is no screen share active right now.
Let me check.
Yeah, there's not.
Yeah, I think it is.
Yes, I don't share active just yet. Go ahead and remove it and then try one more time.
There it goes.
Oh, there we go. Okay.
Okay, yeah, I got like kicked out a couple of times, but now it works. So let me see. Okay, so what we'll be doing in the next couple of minutes, actually, the next 40 minutes, is try to install OpenSIPS so you can see how simple it is to get all this started. So you basically need to do three things: install OpenSIPS, configure it to communicate with the calling API, and start the calling API. And of course, run the commands through JSON, through WebRTC and JSON RPC. So let's get started. First, what we need, I'm having here a clean machine. So this machine is, it was just booted from DigitalOcean. So it's a Debian 10 Buster. It's completely clean. So what I'm going to do first is to install OpenSIPS. I'm going to apt.opensips.org and select the distribution that I'm using to install, installing the key, and repository, update the package manager, and OpenSIPS and OpenSIPS CLI. Okay, so now we are all set. First thing we have to do is configure OpenSIPS. Let's see what we need to configure here. The first thing is the socket that we're listening to.
Sorry to interrupt you, Ruslan. Maybe could you, maybe it's just me, but maybe can you increase a bit the font in the console? Yeah,
is it okay like this?
much better, at least for me. I'm not sure for the, but just to be sure that everyone is able to read.
Sure. Let's find out our IP. Okay. So we need to set the socket that we will be listening on. So this is the socket that SIP clients will, the IP that SIP clients will need to connect to. The second thing that we need to use is to load the modules that we will be using. First of all, let's load module MI datagram. And we also need the event datagram. These two modules we will be using in order to communicate with the calling API. There's a mandatory parameter that the MI datagram is requiring is data socket name, and it's basically the socket that we are using to communicate with OpenSIPS. It has to be a UDP, and we're listening on localhost port 80. Another module that we will be needing is the dialog module. We will use this module in order to keep track of all the dialogues OpenSIPS has, in order to know which one we are able to transfer, which one we are able to terminate, and so forth. And finally, last but not least, the calling operations module, which is actually the new module that is performing all the logic for transferring, putting calls on hold, starting the calls, and so forth. There are two more things that we need to configure in the script. First of all, is to make sure that the dialogues that we create, the dialogues are created, like our OpenSIPS keeps track of them. So in order to do that, we need to call the create dialog for initial invites. So this is the part of the script where OpenSIPS gets for initial invites. Another thing that we have to do is for sequential or for in dialog requests, which are notifies, we need to make sure that we handle them notify as call transfer notifies. So call transfer notify. This function is used to handle notify messages received from the endpoints. And since the function itself handles them, all we have to do is exit. All right, so now we are all set with OpenSIPS. Let's restart it and make sure. Okay. Okay, started 2 seconds ago. We're all set. So this was the first thing that we needed to do. The second thing that we have to do is to install the Call API tool. In order, I will be using the GitHub page of the call of the tool. This will soon be included in the Debian repository I've just sent you, and the one that I've just used to install OpenSIPS. But since the project is so new, we didn't get that far. The first requirement of the repository is to use Golang 1.14. So what I will be doing, since Buster comes with, I believe, Go 1.11, I will manually install Golang on the machine. This is quite simple. You just need to go to the download page of Golang and grab the archive, decompress it in the root, and you're all set. Okay. Okay, so now we need to have Go inside our path. So we are going to export our path variable to Go/bin. There you go. So now we have the latest Go version that we need. Therefore, all we have to do is simply clone the API as instructed in the installation steps. Okay, I will also need to install make. Cloning the API. And simply run make install. Besides installing the commands, this command will also bring all the dependencies that we are using in this tool. So as you can see, it brought all the dependencies. All you had to do was to run make install. In terms of configuration, what we will be doing is we need to modify the listening interface so that we can listen on the public interface. So again, we will need the IP and modify the configuration file, which is located in etc call API, and modify the host that we are listening on, and put and advertise the public IP. Okay, so now we have both server sets set, both OpenSIPS and Call API. What we need to do is start a test. For this cluecon session, I rapidly wrapped a JavaScript file that is able to show you how easy it create the logic of transferring and starting calls using the new call API interface. All you have to do is create an application that is talking using JSON RPC over WebSocket and trigger the commands that the call API project provides. Okay, so in order to start this, I will need a Python server. Okay, so now it's listening on port 8000. Let's go. Actually, I have it here. There you go. So what I've done now was to start a very small, very simple JavaScript application that is talking with our call API using WebRTC over WebSocket. What we haven't done yet was to start call API process. Okay. We also need to export the path to be able to read it. So this is the go/bin path. All right, so we started the API that is listening on the public IP and 5059 port. In order to be able to understand better the call flows during these scenarios, I will also start in a different terminal, an SNgrep window, just to be able to track the SIB messages exchanged during the call start. So let's see. In this scenario, I will use my account from Rezvan at cluecon.opensips.org, which is hopefully which is actually a Lean phone that I will be using. Let me power it up. There you go. So I got my what's happening? Okay, let me see if it registers. It's not registering. Okay. Oh, actually, yeah. There's one more thing that I forgot to do. My phone is registering using the cluecon opensips.org domain, which is currently, because I forgot to add it as an alias, it's not recognized by this server. So I need to provision it accordingly. Restarting OpenSIPS. Let's see if it gets through this time. All right, so I have it registered now. There you go. Okay, so now we can start the SNgrep console and use our small JavaScript application to call. I will call Bogdan at opensips.org, which hopefully will be able to answer this call.
Yeah, I'm ready here,
Are you
and
ready?
I have a hard phone on my desk, so you'll be able to.
So first, I get a call from the API to me, to Rezvan, which I answered. And then a new call is started with Bogdan, as you can see.
Hello.
Hello, I can hear you.
Yep, me too.
Okay, so we have this window, this small window saying that the caller is Rezvan, Bogdan is the callee. What we can do here is trigger an API call to put the call on hold. Let's do it. The call is now on hold. Again, we can resume the call. Call is resumed. We can also transfer the call, put the call on hold, and transfer it to a different extension. But let's take some time and understand what we've done up until now. So here you will notice that you notice that in SNGrep we have two calls. The first call is from the server to itself, and it's passed further to this SBC. Basically, this SBC is the SBC that that my lean phone is behind. That's because I'm behind the private NAT, and I wouldn't be able to use this to use the server without proper NAT handling. But since we didn't want to get into NAT handling issues during this demo, we just decided to use SBC, which is also an OpenSIPS, but is configured as an SBC to handle NAT traversal and interfaces traversal and so forth. So here we have this SBC. We have this call, which is started from the local server and is gone to my to the initial caller.
So that's more or less the first call that we had in that diagram. If you remember in the slides, basically OpenSIPS starting a call from its side, trying to contact the caller. So that's the first step, just grabbing the caller. That's what we see over here.
That is correct. Yes. So as you can see, this is OpenSIPS sending the message to itself and then relaying it to the caller, which is behind the SBC. Then we got the call answered, ACT. As soon as the call was answered, a refer is sent from the server. A refer is sent to the caller saying, hey, you have to call Bogdan at opensips.org. As you can see here in this URI, we are also using a parameter in order to be able to know the initial call. This is not the only mechanism that can be used to determine this call, but is probably the simplest one and is the default one. As you can see, the refer is accepted. There's a re-invite to put the call on hold from lean phone, but basically this is very this doesn't matter that much. That's because at this point, as soon as the refer comes in, a second call is started. So now, as you can see, now is the SBC, which is basically translates to my phone, is starting to call Bogdan at opensips.org. It comes to my server. As you can see here in the request URI, it has the identifier that we previously seen in the refer to header, so that we are able to match the previous dialog and know how to handle them. This invite is, as any other invites are treated as any other call. At this point, it is treated as an outbound. opensips.org is an external domain, and it's where you can reach Bogdan. This call is made, this call is answered, and ACT. Now, as you've previously noticed, as soon as the call was started, I pressed the call hold button. Let's see what happened. Here, as you can see, the proxy itself originated one invite to the caller and another invite to the callee, indicated inactive media. So basically, this means that none of the parties will be sending any media. So both calls will be seen as being on hold. Both of them accepted the call on hold. As you can see, these messages are not relayed, but basically are eaten, let's say, by OpenSIPS itself, because he was the one that generated the requests using the new module. Then after a couple of seconds, 4 seconds, I pressed the call on hold button, which basically started to resume the call. These are the invites that resumed the call. And finally, I pressed the call hold again, just to make sure I don't double hear Bogdan during this presentation. And this is where the current call stopped. So basically, we have this call here. It is on hold. Let's see what else we can do with it. Well, the first, another thing that we can do is start the call transfer. Unfortunately, I didn't have that much time to add the logic in this nice JavaScript application that I've written. But of course, there are other tools that can talk JSON RPC over WebSocket. One of them is actually included in the calling API project. Let me see. And export path.
So that's actually another cool thing that, okay, you have an OpenSIPS instance, you have an API instance, and you can control and work with the calls from that instance through the API from multiple, let's say, API endpoints. Like in this case, so far, Razvan was using that JavaScript in order to start the call. And in the same time, we can operate over exactly the same call just by knowing the call ID from a completely different terminal, still talking with the same API, but through a different connection. So yeah, you can let's say share the ongoing calls through the on the API from different API endpoints.
That is correct. So what I will be doing now is use one of the tools that is coming with the call API module. I use it to run a call blind transfer, transferring the callee of this. So this is the call ID that I've taken from the call that is being put on hold. So it's the actual call that I have with Bogdan, and I want to transfer it to a new destination, to cluecon@opensips.org. As soon as I do this, you will see you will get a couple of events. Some of the very nice feature of this the new call API is that it provides you a lot of events with intermediate states of the transfer. For example, when the call has started, when the transfer was initiated, when the transfer actually started, what did the callee send? Did it send a 180, 183? So you get all this extra information that you wouldn't have gotten without this new module. Of course, as Bogdan said earlier, you could have got them by scripting them. It would be way harder than, as you've seen, just simply adding like five lines, importing some modules, and that's all. Okay, so let's start the call transfer. Okay, my phone is, I have here a phone registered. Let me answer. Hello?
Hello?
Can you hear?
Yes, I do.
Yep. Yeah,
I got
can hear you as
the
well.
ringing, and my phone says on the display says transfer to cluecon. So
Okay.
I have a double presence at cluecon on the phone and also through the WebRTC over here.
That is awesome. Okay, so one thing that we are seeing here is that we didn't get that many events. The problem is that now the transfer that I've done, basically Bogdan at OpenSIPS.org is talking to cluecon at OpenSIPS.org. Therefore, this scenario, actually this call is not going through our server. Therefore, we are not able to get any extra information regarding the call being transferred. However, if the destination would have been one of the entities behind the same server that we installed, you would have gotten all the notifications and all the transferring states that I was talking about. You have probably seen them earlier here in stashed, okay, like stashed here, all the commands. Let me quickly try to make another call. Are you up, Bogdan, with that? Okay.
Yep, sure.
Okay, I think I already have an ongoing call. Just a second. Okay, so let's call Bogdan. Okay. Is it ringing?
Yep, it is.
Okay, you've probably noticed here 100 trying, the 180s and so forth. Can you answer, Bogdan?
Oh, yeah, sure, sorry. I was just
Okay.
looking because I don't think that the capturing of the screen is displaying those notifications because I'm not able to see them either.
Okay, I'm sorry about that.
Yeah, because it's a notification system. I'm not sure exactly how the capturing it's done of on the.
Okay,
yeah.
so sorry about that. You probably have to believe me. There were some notifications that popped in the screen showing the different states that the call is in. Unfortunately, my screen share didn't.
That sounds like starting a new religion. Everything starts with believe me.
Exactly. This is the OpenSIPS Call API religion. What we can do now, another operation that we can do, and is quite simple, is to terminate the call. So simply call end will simply end the call.
Yep.
There are a couple of notifications here as well, but I'm sorry about not being able to see them. Okay.
Redwan, what if we start the call through the console? Because in that case, you will get the notification in the console.
Sure, that's a very good idea. Let's do that. So similar to the way we started the call transfer, let's do a call start. Call start command having SIP. Call is open at OpenSIPS.org. Okay. Is it ringing for you? Oh, actually, I didn't terminate the previous call. Just a second, I didn't terminate the previous call. Okay. Okay.
Yeah, ringing now. So pick it up.
Okay, so okay.
So if you can just highlight the event, just for the people to see them.
As you can see, we had like 1, 2, 3, 4, 5, 6 different events. The first one is the call being executed. Then we got an event saying that Bogdan has answered the call. And as soon as actually not Bogdan, the caller, in this case, Razvan, has answered the call. This is the call answered event. As soon as the call was answered, a refer was triggered. And in that moment, a transferring event popped in saying that Razvan is now calling destination Bogdan. When the transfer starts, basically this means that Bogdan has actually my phone, Razvan, has sent an invite to Bogdan to join the call. And at this point, we also have, as you can notice, we have the call ID of the new call. So this is the call that is basically is ongoing now. Then we get some information saying that the call is that the server is trying to reach Bogdan, and then we get the final event saying that the call has been answered. Right. So what we can do now is use the console to operate with this new call. For example, we can do the same thing like call hold, call ID. Let's hold this call ID. Okay. You'll also get some debug, but you can suppress this using configuration. Here you'll get events for each call whenever each call gets put on hold. Similarly, we can unhold the call. There you go. So you have each events for you have the events for each leg of the call, and whenever the call starts to be resumed, and similarly call end, which will terminate the call. Actually, call terminate, I think. Oh, no, actually, no. The initial call end did work. We just didn't get any events because there's no events to get. As you can see, if I try the call end second time, the dialog was no longer found. So it was terminated initially. So bottom line, these are some of the tools that some of the commands that the Call API provides. There's also both call attended and unattended transfers. So you can just take the Call API and play with them, make your own calls, start transferring them, and so forth and so on. And let us know if you have any requests. If you want to develop this project, as you've seen, is open source, so you can always contribute pull requests and even with ideas and so forth.
A note, the Call API doesn't want to actually expose kind of a SIP endpoint. So through the API, you cannot create a SIP endpoint. It gives you the possibility to operate, to work with existing SIP endpoints. So basically, you still need a phone, a SIP terminal, whatever it is. The Call API will just help you to control the calls in relation with the device in a nice manner. For example, maybe you want to build in a web portal some kind of let's say kind of a VoIP service, and you want to do like a click to dial from an address book. So in that case, clicking on an address in the web interface can translate in a call start. So your own device on the desk next to you may simply start ringing. You can pick it up. So you still use the traditional SIP device, but you don't dial from it. You don't need to, let's say the phone doesn't have to actually support any kind of buttons to on hold, off hold, or transfer. You can do all these kind of things from, let's say, a nice web interface, and you can use the SIP phone as a simple dummy audio device, nothing more than that. Again, the whole control of the call can be done through the API. I mean, that's the idea of the API, is to first give you the possibility to remotely interact with the calls going through the OpenSIPs, and secondly, to expose a higher level of working with the calls, because I'm not sure how many of you actually had let's say the opportunity to work with the OpenSIPS config file, but this config file is quite let's say SIP intimate. So basically you have to know a lot of how SIP works, and then you have to learn a lot of things about OpenSIPS in order to to implement a more complex routing into OpenSIPS. But the API can simply provide all this already packed, so you just have to use them through the API. You use OpenSIPS like a SIP stack, and that's it. You don't really have to understand and bother with, let's say, how SIP works, or how you have to put together, I don't know how many features or functionalities in OpenSIPS in order to, make it work. So just to be sure that it's a clear understanding on what's the purpose of the API. So it's not a replacement for an SIP endpoint. Is a way to manipulate calls through existing devices. Razvan, do you want to take the questions? They are on the
sure.
Slack. Okay.
Sure. So yeah, we've got a couple of questions. First of them is, does it make sense, or is it possible to use OpenSIPS with SignalWire REST API? And whether there's any examples for using the call API with C#. I will answer the first one because it's easier. There are currently no examples for using C#, but we are planning to develop different examples for different languages. So make sure you subscribe for any event or any news from OpenSIPS regarding the Call API project. For the second question,
sorry to interrupt you, Razvan. If I may complete a bit the answer here. Actually, that was we took this into consideration when we designed the API, and we said, okay, we need in terms of transport and packing to come up with some ways that are very easy to use from whatever kind of language you want to use for implementing an API client. So that's why I said, okay, let's use WebSockets and as a transport, and that's why let's use JSON for packing the data, because you'll find libraries for WebSockets and for JSON in almost all languages. So even in most probably in the high level languages, maybe like Python or whatever, it will be quite trivial actually to have an API client.
Right, that is correct. So yeah, it should be pretty trivial for you to implement your own the WebSocket JSON RPC commands using your preferred languages. Should be quite simple. And regarding the question whether whether it makes any sense to use OpenSIPS combined with REST API. As Bogdan said earlier, OpenSIPS is not a B2B user agent, so such as FreeSwitch, for example. So we are not able to handle media and so forth. all we can do is realize like making the connection between two calls and basically play with the SIP endpoints between them. The nice thing is that we can do that with simple proxy dialogues that offers us a lot of flexibility and a lot of in the high throughput in performance. So that's great. As far as I know, the SignalWire API does a lot more than that. So we're not trying to compete with it. We're just trying to make our proxy call to be as flexible and as easy to control as possible. Going to the next question is which component is in charge of producing RTP or media? Just as Bogdan said, basically the phone itself. So we are not a media engine. We're not going to generate any RTP traffic. All we will do is link to. So we can't be one of the SIP endpoints. We will still be a SIP proxy, not UA.
So in
Are there any
the
other
example
questions?
that we had at this point, basically the media was flowing directly between the endpoints. So the RTP was not even going through the to the OpenSIPS machine. Of course, if you want to do that, for example, to cope with different kind of clients, or for network bridging reasons, or for clients, I mean, in terms of using RTP, SRTP, or whatever, you can use an external media relay which works out of the box with OpenSIPS, like RTP proxy, RTP engine, media proxy, so one of them, depending on the purpose. And it worth being mentioned here that actually we can produce RTP. There is a new feature in 3.1 in OpenSIPS 3.1 release. It's called the Media Exchange module, which allows OpenSIPS to exchange RTP streams between ongoing calls. So basically, with something like that, if you have an ongoing call, even if it's in a proxy mode, so between A and B, OpenSIPS from the middle can actually start injecting, let's say, RTP in order to do something like music on hold. And this is done by this exchange, the media exchange module, in a very simple way. It starts new calls to a media server, let's say to a free switch, in order to get the RTP playback, and then exchanges through an reinvite SDPs with the original call between A and B. So basically, it takes the SDP and eventually the RTP from free switch and sends it to A, let's say to party A, and probably completely a different one. It may be sent to party B in the call. Still, in terms of signaling, it's still a call directly between A and B in proxy mode, so it's not in back-to-back. But we are able, using this exchanger module, to play with the RTP streams, so to import RTP streams from other calls and push them into the original call. And of course, we can do the other way around. I mean, not injecting, but actually getting and cloning the RTP going between A and B and send it to, let's say, a media server for different reasons. For example, you know, so you don't have to actually put the call through a dedicated box. We just clone the stream, the RTP stream, and we create a new call in order to send it to a new SIP destination. So that's a very nice and light way of doing, probably I would say like 90% of the scenarios involving media related features in the VoIP calls.
That is correct. Thank you, Bogdan, for adding this. There's another question here, which is going to be the last one. Using call API in dialog action, hold, on hold, refer, can we modify, add, remove some SIP headers? The answer is yes. The only limitation is that this has to be done prior in the script. So you have to intercept this event in the local route, if you're familiar with OpenSIPS scripting, where you can do whatever you want with a message like drop whatever headers, add whatever headers you want. You may also have access to the dialogue that it's being generated for, so you can get a lot of informations. And the only limitation is that you can't actually do the change from the command itself. So it has to be prior done in the prior scripted in the local route. All right, so I guess this was the last question. Thank you guys so much for having us at the cluecon this year as well. And thank you all for being present at this hour. I'm not sure how early or late it is for you, but thanks for being here. And looking forward to seeing you next year at cluecon, hopefully.
I mean, to a real cluecon.
To the real, yeah. I said seeing. Well, yeah, meeting some of you over there.